I say, we're doing compound angles today. So just quickly before we jump straight into it, has anyone started trig at school? You can just give me a thumbs up or a thumbs down. So obviously different heads of departments do things differently. Okay, Siba, you started. Latawa, nice. Okay, it's more than another class. Different schools do things differently. Some heads of department decide to do trig early, some later. I know personally, I think we only do trig in middle of term 2. Bongi and Kosi, okay, awesome. So yeah, we don't start trig until term 2, and we leave calculus all the way until term 3. So schools do things differently. You're either getting a recap of what you've already done, or you're getting ahead of the game. So when it comes to you sitting in lessons, you do know what's going on, and you can start to apply your knowledge to more complex questions. Either way, you're benefiting. Okay, so most of us have actually started trig. That's awesome. Okay, so given the fact that most of you have started trig, can anyone tell me what a compound angle is? Just like basically, what is a compound angle? Siba, I think you asked me this last time, and I don't know what you mean, if I'm being honest. So I split trig, if I really was pushed to answer that, into 3. General trig, which is what we're doing now with the identities, expressions, equations, all of that stuff. Trig functions, and then 2D and 3D trig. So I would split it into 3. Obviously people do it differently. We are only really looking at the general trig, the trig functions and trig in triangles, or 2D and 3D trig is sort of independent work for you guys. We're focusing on the main general trig, which is the bulk of your exam. So I'm assuming your teacher does split it into 2 parts. I would assume the 2 parts would be general trig and then trig functions, but obviously correct me if I'm wrong. So yeah, personally, I don't split it into 2, I split it into 3. But for the purposes of this course, we're only focusing on the general trig, because that is the bulk of it. Excuse me. Nice, Latabo, thank you. Okay, so guys, a compound angle involves a trig ratio, whereby we are looking at the sum, or difference between 2 different angles. Difference. Now this can look, I mean, there's an infinite number of examples I could give. But essentially, if you're going to add 2 different angles together, if we think of this in terms of our Cartesian plane, here we have, let's say, for example, an angle of 60 degrees. And we've got an angle, say, for example, of alpha. Our compound angle here, if we wanted to consider the entire angle, would be 60 plus alpha. It's the sum of 2 different angles. The difference of 2 different angles, again, there's an infinite number of examples I could give. Let's say, for example, we had the angle 80 degrees, and we had the angle beta. If I wanted only this portion, this would be 80 minus beta. And that's essentially what a compound angle is. We've got formulas that we need to apply when it comes to our compound angles, which I'm going to give you in a second. These are on your formula sheet, so you do not need to learn them off by heart. You do not need to learn them off by heart. They are on your formula sheet. Obviously, you need to be able to look at the formula sheet and identify, but you can quite clearly see what the trig is. And remember, I've put on the Google Classroom annotated formula sheet of all the different sections and their formulas. So these are the formulas that you need to know. Again, they're on your formula sheet, but as you can see throughout the lesson next to the examples that we're going to do, I've put the formulas for us just so that you don't have to keep referring to something that you've screenshotted. Also, so that you don't have to try and scramble to find a formula sheet. They're there. Okay, just makes life so much easier. Right, so take a screenshot of that first little bit if you would like to, but we're going to now start applying these compound angle formula to different scenarios. Like I say, we're going to have a look at the basics today, expanding the formula, simplifying some basic numerical examples, and then on Monday, we're going to step it up with the types of questions you can expect. So if we have a look at this first example, sorry. Again, I've given you the formula there. You don't need to go back to a screenshot. You don't need to revise anything or try and remember it. It's there for us. We want to expand these examples. So essentially all we want to do is we want to look at what we've been given and we want to match it up to a formula. So if we look at this first question, cos of x minus y, we're talking about a cos ratio that is talking or dealing with the difference of angles. So we go to our formula, again, it's on your formula sheet. You find the one with the difference, which is this very first one. And that formula expands to cos of the first angle times cos of the second angle plus sine of the first angle times sine of the second angle. Now, what you'll notice with the cos ratios, if I just grab a different color here, what you're going to notice with the cos ratios is that if it's a negative or difference between two angles, the expanded form has a positive. If it is the sum of two angles, the expanded form has a negative. So the sign is always different. Whereas with your sine ratios, if it's the difference between two angles, your expanded form will be the difference. If it's the sum of two angles, the expanded form will be the sum. So those signs match up. For cos formulas, it's cos plus or minus sine sine. For the sine ratios, it's sine cos plus or minus cos sine. So it has different trig ratios in each of your terms. Whereas cos, the first term is cos, the second term is both sine. Again, you don't need to learn these off by heart because you get given them on the formula sheet. Just something to bear in mind. So because we know which formula we're now going to apply, we can just go and expand it. So, okay, apparently it's not going to work there. Your cos a minus b formula, or x minus y, is cos of x times cos of y. Now remember the signs change, so plus sine of x times sine of y. And that's it. We have expanded it. There's nothing more that we can do. Obviously, if you had like special angles or something going on, you could deal with it. But in this case, because both of our angles are unknowns, I can't simplify anything. That is it expanded. If we then have a look at question B, so now we've got a sine ratio that we're working with. So we've got sine A minus 20. We go to our formula and we decide which is going to work. It's A minus B, so the second formula down here. And remember the sine one, the signs are the same. So because this is the difference, it will be the difference. And sine is the one where it's sine cos, cos sine. So the two different ratios. So this is going to simplify to sine of the first angle, which is A, times cos of the second angle, which is 20. Sine stays the same, so minus cos of the first angle times sine of the second angle. Now those 20 degrees are not like terms, something I can factorize. That's it. You've expanded, done, blah, nothing more. Again, this might seem basic, but if we can do this basic stuff, it allows us to apply it to our expressions and our equations and all of those other things. And that we will look at on Monday. Okay, if we look at C. So C is sine of 2 alpha plus 45. Now immediately alarm bells should be going off in your head because 45 is a special angle. So already somewhere I should be thinking I'm going to have to apply a special angle. But before we get there, which formula are we applying? Well, it's plus, and it's a sine, so sine A plus B. And this will be sine A times cos B plus cos A times sine B. So sine 2 alpha plus cos of 45 plus cos of 2 alpha times sine 45. Now cos 45 and sine 45, because you've got those special angles there, you can actually go and simplify them further. So just to remind you of your special angles, because I know it's one that I can't really always remember, but honestly, grade 12s, it'll say without a calculator, use the calculator. As long as you show me all of your working out and you don't all of a sudden go from a whole bunch of like sine 45 times cos 60 divided by tan 1, whatever, all the way to an answer, you just show your substitution of each of them. That's fine. If you need your calculator to double check a ratio, that is absolutely fine. All right, so triangle, you've got a bunch of different spatial angles that you need to know. So the spatial angles on your Cartesian plane are the 0, 90, 180, 270, 360. That will correlate with your trig functions. You can go back and look at those if you need to. Otherwise, again, just use your calculator to show all of your working out. But the acute angles that we focus on are the 60-degree angle and the 30-degree angle, as well as the 45-degree angles, which I will draw a separate triangle for, obviously. Okay, so I don't know how many of you learned your spatial angles like this at school. I know this is how I was taught them. You learn your triangles. It's a 1, 2, 1, 2, 3. So 1, 2, root 3 triangle for the cos, or for the 60 and the 30. 45 is root 2, 2. Some of you might have learned it as 1, 1, root 2. It doesn't matter. Okay, it's the same thing. So what this now means is I can go and simplify to a single numerical ratio, cos 45 and sine 45. Now, if you go to your triangle, it makes no difference which 45 you look at, they're the same angle. So sine is opposite over hypotenuse. So it'd be root 2 over 2. Cos is adjacent over hypotenuse, root 2 over 2. So these will both simplify to square root 2 over 2 times sine 2 alpha plus root 2 over 2 times cos 2 alpha. Now, great souls, remember, it doesn't matter that I'm writing the sine 45 ratios in front. The order in which you multiply doesn't matter. 2 times 3 and 3 times 2 both give you 6. So you can swap the order of your factors. That's not a problem. And what you can now see is that you can factorize this to get a single simplified term of root 2 over 2 times sine 2 alpha plus cos 2 alpha. Sine 2 alpha, cos 2 alpha aren't like terms, so we can't really add them, but that's it. When there are spatial angles, we need to apply it if we can. If there aren't spatial angles, we stop. So like in the first two, there's nothing more I could do except for expand. But if I can simplify further, I do. All right, so let's take a screenshot there, and then you're going to try some examples for me. Obviously, grade 12s, remember, if you do have questions as we go along, please just ask. Pop it in the chat, raise your hand, completely up to you. Yes, Josh, it is double angle. We're not going to introduce the double angles just yet, but yes, it is a double angle. So guys, you do have double angle formulas that you can work with, which we will chat about next week, Wednesday. We will start talking about double angles. I just have to think about it. But yes, it is a double angle. Well done. Double angles 2 times the angle. It's double alpha. So if and when we can apply our double angle formulae to simplify further, we absolutely will. For now, I'm just going to stop here just because we're not focusing on double angles, but yes, it is. All right, so remember, we're just doing the basics for now. We'll deal with double angles and the applications thereof next week. But well done on picking that up. All right, so guys, these are the 2 questions I would like you to try, please. Sine of x minus 50 and cos of 60 minus theta. Already in your head, you should be thinking 60 is a special angle. I'm going to have to do something there. So I will just leave those special angles up, triangles up for you. But let's have a look. All right, so give them a try. I'm going to give you 2 or 3 minutes, and then we'll have a look. Okay, let's have a look. Right, so first one, you're expanding, it's a sine ratio. So what that means is you've got the sine, cos, sine, the signs match up. So because it's sine of x minus 50, it'll be sine cos minus cos sine, which is what I've got there. That x means that we can't really do anything more than that. 50 is also not a special angle. Done.
Ma'am,
Second one, yes, sorry.
for A, will I be wrong if I say sine x times sine 50 plus cos x times cos 50?
Yeah, so just be careful if I pop up back here to our compound angle formula, because it's sine of an angle minus an angle, we need to use the appropriate formula. So sine of angle minus an angle is a sine cos term and then a cos sine term. Sine sines, so sines together and coses together, are the cos formula. So if you have a look here at the cos formula, cos of a plus b or a minus b, this is where we have the coses together and the sines together. So it's a completely different formula when they're together. So we do need to have sine and then cos and then minus cos and then sine. Okay, I hope that made sense. So guys, what I would always do is I would have my formula sheet, and granted I should have put the compound angle formula here next to this. So that's on me. I should have done that for you guys. Match it up to what you have, and then you quite literally just copy the formula from there. Sorry, just decided to jump through the window and give me a fright. Second one, cos 60 minus theta. So if we just look at this compound angle formula here, it's cos. So we're going to look at these first two, and then it's the difference of the angle. So we're actually considering this first formula here. This will now be a cos, sine situation. Because it was negative, we're now working with a plus, and so we can fill those in. Now cos 60 and sine 60 are special angles, so we can simplify those further. The ratio of cos 60 is a half. The ratio of sine 60 is √3/2. Okay. The table S in sine is for the same sign. C and cos is for change the sign. Oh, I love it. Love when you guys give me like new things that I can use. Okay, I'm actually going to write this out. S in sine means same sign. C in cos change sign. Love it. I'm also going to use this in my classes. So thank you, Latable. Love when you guys give me things. Alrighty, guys, but let's take a screenshot of those two. I wonder if we can. Right, love it. Sorry, guys, I just need to throw my cat out here. She's going to cause absolute chaos. Screenshot, and then we're going to have a look at the second example. Alrighty, so if we have a look at example 2, we're now going backwards. So we've got the expanded form, and what we now want to do is simplify to the single ratio. So again, we're going to match up the information that we have. Here in our first example, we've got sine 2 theta times cos theta plus cos 2 theta times sine theta. Now, the first thing you do want to do is just make sure that your angle A's match up with your angle B's. So you could write this as sine of angle A times cos of angle B plus cos of angle A times sine of angle B. So what you see is that both B's are theta and both A's are 2 theta. So they do match up. We don't have to do any swapping, changing, anything like that. They match up. So now we can go and decide which ratio it is that we're working with. So because we've got a sine, cos, sine, what that means is that we're going to be working with the sine ratio, because remember, those two are the ones where we've got sine, cos, sine. And then because it is the sum, as the table has just told us, sum, same sign, so we're working with the sine A plus B. And if you have a look, it matches up. Sine A, cos B, plus cos A, sine B. That's perfect. We can now go and simplify to our single ratio. So it's going to be sine of the first angle 2 theta plus the second angle theta. Now that's actually like terms, so you can go and simplify it to sine of 3 theta. And we have simplified to a single trig ratio. So always try and match up your ratios with the formula that you have been given. Right, if we have a look at the second one, again, if we just write out, we've got cos A times cos B plus sine A, whoopsie, times sine B. Angles match up, both B's are X's, both A's are 70, so we're happy with that, that's not a problem. Now, the difference here is I've got a cos, sine, sine. Cos, sine, sine means I'm dealing with a cos ratio. Let's see which one. So remember, as Otavo said, it's cos, change of sign, so it should be a cos minus, but let's have a look. Cos plus sine, we're looking at this first ratio, and so yes, indeed, it is cos A minus B. So we can simplify this first ratio to cos of the first angle, 70, minus the second angle, x, cos of 70 minus x. No like terms, no special angles, we're done. Right, if we look at example 4, again, if you try and match up what you have, sine A times sine B minus cos A times cos B. What I want you to notice is that the B angles don't match up. One is 5 theta, one is 4 theta. The A angles don't match up. One is 4 theta, one is 5 theta. So we've got a bit of an issue, right? We can't apply the formula if those angles aren't matching up. Now, the first thing I'm going to say is, remember, order of multiplication doesn't matter. We can very easily swap those terms. That's not an issue. Okay, we've got a sine, cos, situation. Sine, cos means a cos ratio. We'll get to that in a second. Let's first write our factors in the correct order so that the A's match up and the B's match up. So I'm going to leave the first one as it is, sine 40 times sine 14. Sine 4 theta times sine 5 theta. In the second term, I can just swap these factors. Cos 4 theta times sine 5 theta. Now my A and B angles match up. So now I'm happy. I'm just adding degree signs everywhere in the way. Now the A and the B's match up. That's awesome. The next thing I now need to check for is which formula it applies to. Now guys, if you go up to your formulas, also cos 5 theta, got there in the end. If you go and have a look, remember we've got a sine, cos. None of these formulas start with sine. Both of the sine, cos formulas start with cos. Now you can't just swap the terms, okay? What we need to remember is that the sine needs to stick with the term. So if I were to swap these terms to put the cos term first, I would have minus cos 4 theta times your cos 5 theta plus sine 4 theta times my brain, sine 5 theta. So the problem now stands that I've got that negative in front of my first term, but that's not a problem. We all know algebra, we can do algebra. Just take the negative out as a common factor. That means we've got minus cos 4 theta times cos 5 theta minus, because we've taken the negative out, sine 4 theta times sine 5 theta. Now you've got your causes first. The cos is positive, which is what we want. We can decide which formula we're using. It's minus, so it's the change of sign. So we're working with cos A plus B. So this is negative cos 4 theta plus 5 theta, which means we're working with negative cos 9 theta. Right, and this is where, I said this on Monday, this is where you need to be aware of the fact that algebra is a part of your life, regardless of the fact that it is considered a paper 1 topic. Algebra is in geometry, in trig, in stats. It is part of your life in maths. All we have done here is apply algebraic skills and knowledge. The algebraic skill of multiplication order doesn't matter. The algebraic skill of factorizing out a negative. The algebraic skill of expanding and simplifying. Okay, so this is algebra, but instead of x's and y's and a's and b's, we've got sine and cos. And that's what you need to think of trig as. It's just algebra, but the variables are sine and cos, tan, whatever it is we're working with. Okay, guys, so let's take a screenshot. And then you're going to try some by yourselves. And remember, obviously, if you've got questions as we go along, please just ask. All right. These are the 3 examples I want you guys to try. I will give you a bit longer because I've given you 3, so 5 minutes, and then we'll double check. I have made a mistake with one of these answers, so when I show the answers, I will fix it. I was just being really silly. Right, but let's give them a try. Obviously, again, if you have questions as you're working through them, just ask. Use the skills that we used in the first 3 examples to now apply here. And please also remember, I was going to say special angles, but there are none. So off you go. Okay, guys, I'm going to give you another minute and then we'll have a look. Maybe another 2, just because I'm seeing answers coming slowly, but not, obviously you don't have to put your answers if you don't want to, but it does give me an idea of how long we need. So guys, just while you're finishing off, most of it because I genuinely can't remember what I said at the start of the lesson. Just a reminder, there is a whole bunch of grade 11 revision on the Google Classroom for you guys if you need it. I do think I said this as I'm saying it now. I'm getting deja vu. But it's been a long term and we're all tired. So I'm just reminding you that it's there for you if and when you are revising during the holidays, which you should be. Because like I say, you've got like 10, 11 weeks before finals. And we should be on it. All right, but let's have a look. So like I said, the first answer I just clearly was tired. I'm going to fix it now. 3 theta minus theta is 2 theta. So there we go. But other than that, we're all good. So remember, think about the formula you are working with. Cos, sine, we're working with the cos formula, etc., etc. The table's given us that neat little reminder with our signs. So remember that as well. I'm even going to add it to my notes, the table. Like, see, this is why like maths is so cool. We all think of different things. And just because I thought of something doesn't mean it's right. It doesn't mean it's the only way. Anyways, I digress. B sine 2p. And then say sine 2p. Sine 2p. And C sine 4x. That is how we simplify these 3 examples. All right, so I'll leave it up there in case you want to take a quick screenshot. Otherwise, we're going to have a look at some numerical examples where we now need to work with actual values for our angle in order to simplify. And this is sort of starting to lead up to where we're going to be on Wednesday, looking at the types of questions you're going to encounter. Okay. Alrighty, so without the use of a calculator, calculate the value of each of the following. Now, sometimes, or most of the time when we say without the use of a calculator, you're probably going to have special angles. I'm just going to put it out there now. In both of these examples, it's not special angles, but we want to essentially simplify it to one single trig ratio, which is what compound angles allow us to do. If we look at the first question, so you can just ignore question B for now. If we look at the first question, we've got cos 320 times cos 20 minus sine 140 times sine 200. What? No. All of the angles are different. We can't just go and apply a formula. So this is now where we need to start applying the knowledge we have from trig. So when we have situations like this, there are a couple of things we want to remember. First thing is our reduction formula. Sorry, I'm clearly having the time. And your reduction formula relates back to your cast diagram. Okay. So cast diagram and all of your reductions that you know. So 180 minus theta, 180 plus theta, 360 minus theta. And guys, in a testing exam, I say it as if I'm still writing testing exams, but draw the little cast diagram, add your reduction formula. It's there for you. Okay, the second thing you want to remember are co-ratios. So the co-ratios that we have spoken about, most importantly, are your 90 plus or minus co-ratios. Remember, this is where the name changes and sometimes the sign changes. I did briefly mention the 270 co-ratios, but honestly, I wouldn't use them. If you can avoid them, do. You don't have to, and you can apply it in different ways, but personally, I would avoid them. There's more sign changes and name changes than the normal 90 plus or minus. You're just creating a situation where you could potentially mess up. So if we can avoid it, avoid it. Those are the things that we need to remember when it comes to these sorts of questions, exactly as Josh has said there on the chat, reduction formula. Trig is about reduction formulas at the end of the day when it comes to grade 12 stuff. Now, guys, the other piece of advice I'm going to give here is that if you have an acute angle, leave it. Now, the reason I'm saying that is because the only way you can change an acute angle is through a co-ratio. Co-ratios should not be your first port of call. Okay, the co-ratios we deal with later if we need to deal with them because they are slightly harder with the name changes and with the sign considerations. We're going to start with reductions. If we need to deal with co-ratios, we can do so, but let's not do it if we don't have to. So we're going to leave any acute angles that we have. We're going to deal with the other ones If we need to come back to it, we come back to it. That's not the end of the world, but we're going to leave it. So the only acute angle I have in this first example is cos 20. Everything else I'm going to change. So cos of 320, okay, it's not going to work there, can be written as cos of 360 minus 40. Then we've got our times cos 20, which we're going to leave, minus sine of 140 can be written as 180 minus 40. Now, already what you can see is that these first angles are starting to match up. They now at least both have a 40 in them, and when we apply our reduction, they'll both be 40. Times sine of 200 can be written as 180 plus 20. And hopefully what you can now see is that once we've applied the reduction, the second angles are now going to be the same. So through our knowledge of reduction formulae, we are able to go and simplify this. So 360 minus quadrant 4 cos is positive, so this is just cos 40 times cos 20 minus 180 minus quadrant 2 sine is positive, so sine 40 times sine, times sine 180 plus is quadrant 3, so this is where sine is negative, so negative sine 20. That says sine and that says 20. We're just going to roll with it. Now just be careful, in the second term you've got a negative times a negative. So what it's actually going to simplify to is cos 40 cos 20 plus sine 40 sine 20. But now, apparently I can't spell sine tonight. But now we're able to match up which reduction formula it is we're using. So if we look here, we've got a cos, cos, sine, sine. So that means we're looking at cos ratios. It's the sum of, so this is where the sign is different, cos A minus B. So this simplifies down to cos 40 minus 20, which gives us cos 20. Obviously, if this had been the other way around and it had been the sum of 40 and 20, you would get 60 special angle. You can then go and apply your special angle rules. In this case, it doesn't. So we just stop at cos 20. We've simplified as much as we can. Right, when it gets to the second question, again, what we have is a bit of a conundrum when it comes to our angles, because all of the angles are different. We've got cos 10 times sine 160 minus sine 10 times sine 110. Now, alarm bells should be going off because the angles are different, but you should also have a secondary set of alarm bells going off because we don't have any formula. So if you go back up to this block, you have no formula that have cos sine in your first term and then a sine sine in your second term. It is either first term both cos, second term both sine, or it is first term cos sine, or sine cos rather, second term cos sine. So this is not a possible situation. Because of that, I know that I'm going to have to change one of those either to be a cos cos in the first term, or in the second term change one of those to be a sine cos. So either way, I'm going to have to use a co-ratio here. So these are the things we need to start thinking about as we go through examples like this. Again, I'm going to leave my acute angles. If I need to change them later, I will change them later. But if I don't need to change them, don't. Right. So I'm going to leave them for now. I can come back and deal with them if I need to. So we've got cos 10, which I'm going to leave. Sine 160, we can write as sine 180 minus 20. Minus, I'm going to leave the sine 10 for now. Times, now, 110 can be written as sine 180 minus 70. Okay, so I still have a conundrum of my angles not matching up, but 20 plus 70 is 90, co-ratio, no problems. So I already said I'm going to have to apply a co-ratio. That was a foregone conclusion. But now I can see that those co-ratios do exist. Remember, the key or the hint you get if you're going to use a co-ratio is that the angles, when you add them together, should give you 90. 70 plus 20 gives me 90, so I'm fine. So let's just simplify these reductions. Cos 10 is cos 10. 180 minus for sine, positive, so we've got sine 20. Minus sine of 10 degrees times 180 minus, again, positive, sine of 70. Right, so now you've got some options. either you can go and change, either you can use your co-ratios to go and change the sine 20, or you can use your co-ratios to change the sine 70. Whichever one makes absolutely no difference. We have a bit of time, so I might even be able to do both for you so you can see it makes no difference. So I'm going to change the sine 70 to start off with. I can do the sine 20 in a second. It's not an issue. So everything else is going to stay exactly as it is. This is the only one I'm going to deal with. Right, so sine 70, I could actually write as sine 90 minus 20. And because of the co-ratios and because of what we're wanting, hopefully what you see is that the 10s already match up and now the 20s are going to match up. Awesome, I can now apply my formula. However, because it's a co-ratio, we've got sine 90 minus, there's a name change. So I've got cos 10 times sine 20 minus sine 10 times name change to cos 90 minus, everything's positive, so cos 20. Wonderful. Now I've got something I can work with. If you go back to your ratios, you've got a cos sine, sine cos. The ratios we work with are sine cos, cos sine, so they actually swap. But remember, you can swap your factors. It makes no difference. So you can write this as sine 20 times cos 10 to get it in the order of your formula. And then cos 20 times sine 10. Doesn't really matter. It's the negative, so it's the difference between. So we're working with this first formula over here, sine A minus B. So this would be sine of 20 minus 10, which gives us sine 10 degrees. Simplified, whoopsie daisy, sorry guys. Simplified to one single trig ratio. Right, just for interest's sake, if you did not work with changing the sine 70 and you made a choice to rather change the sine 20. So if we have a look at that scenario very quickly, this would be cos 10 times sine of 90. Apparently that is 90. Okay, cool. What do you want from me? Okay, 90 minus 70, everything else the same. So minus sine 10 times sine 70. So again, you can see that the 70s are matching up, so I'm happy with that. This would then give me cos 10 times name change, co-ratio, cos 70 minus sine 10 times sine 70. It's a cos, sine, sine situation. It's the difference between, so we're working with this formula over here. And so this would simplify down to cos of 10 plus 70 degrees, which gives us cos of 80. Now, the reason I know that both of these answers are the same are again because of co-ratios. 80 plus 10 gives me 90. Sine and cos are co-ratios to each other. We're sorted. No issues whatsoever, regardless of which way you choose to do it. You're going to find with trig, and I did say this to you on Monday, that oftentimes there's different ways to do things. Sometimes you even end up with different answers. The answers are actually the same, but because of the co-ratio relationship, they look different, but are actually the same thing. All right, so either one would have been absolutely fine to deal with, whichever one you see first. But the hint with co-ratios is if your angles add up to 90, you've got a co-ratio that you can work with. All right, so I'm just going to make this a touch smaller so you can screenshot that example. And then I'm going to put up 2 for you guys to try in these last 7 minutes that we have. All righty. Okay, so I want you guys to try these 2 for me. Remember, if you do end up with special angles, make sure you apply those special angles. Like I said, there's 7 minutes. I'm going to give you 6 of them to do it. And then the last minute, I'll put up the answers for you to screenshot. but let's give these ones a try. Oh, Bongi and Kosi, I'm so sorry. Guys, I'm assuming you've got the co-ratio somewhere. The co-ratio compound formula somewhere. Bongi and Kosi, just let me know if that's fine. If you need me to zoom in more, I obviously can. Just let me know. Awesome. And guys, remember, like I say, if you get special angles, deal with them. Okay, I just put the compound angle formula at the top here, just so that if you do need it, you can actually see it all now. Okay, guys, let's have a look. We might not be finished, and that's absolutely fine. You can just take a screenshot of it. So I'll explain what's going on here because there's a fair amount going on. So just quickly, the stuff that is on the right-hand side is just my reduction formula stuff going on. So this stuff is just the reduction for both of the questions. I don't know why I only circled that one. These are the reductions. So don't stress about that. You obviously do not have to show that. It was more so that you could see how I went from sine 280 to negative sine 80. Right? Show it, don't show it. If you need to do the extra step of sine 360 minus 80, and then in your next step, negative sine 80, fine. But if you do skip straight to your simplified reduction, that is also absolutely fine. I'm just showing you how I got those there. Okay, so in the first one, so Bongi and Kosi, I initially also got a sine 120. Just bear in mind that sine 120 as a reduction could be sine 180 minus 60, which reduces to sine 60, which is the same thing that I have here. And it goes back to that idea of any trig ratio. No, let's try that again. Any trig ratio of an angle. So sine, no, my words are getting mixed. I'm going to start that whole sentence again. You can get the same trig ratio for two different angles. So the ratio of root 3 over 2 you can get for 60 and you can get for 120. And those repeat every 360 degrees. Goes back to the idea of equations. So the sine 160, because it can be reduced to sine 120 can be reduced to sine 60. We can go that step further and use the special angles. Then in question B, you ended up with sine 25 plus sine 65, which is sine 90. And just that you guys are aware of how I got 1, if you think of a sine graph, it starts at 0, goes up, down, and such. This peak is at 91. So sine of 90 is 1. And that's what I was saying earlier. If you go back to your trig graphs, there's a lot of special angles on those Cartesian plane axes, 0, 90, 180, 270, 360, that are special angles. And those are ones that we need to know as well. But they go back to your trig graphs. Alrighty. So guys, take your screenshots.